Dalton's law of partial pressure is a law that we use to describe containers of gases that contain more than one type of gas. Now, it's unusual in the real world to find just helium gas, just hydrogen gas. Normally there's a bunch of stuff mixed together. Like our air contains a lot of nitrogen, some oxygen, some hydrogen, and other trace elements as well. So when we know for Dalton's law, it says when there's a mixture of gases, the total pressure is the sum of the partial pressure, which sounds a bit confusing, so let's break that down. The partial pressure is how much pressure a gas exerts if it's by itself. So when we talk about the partial pressure, we're looking at the pressure of just hydrogen, or just helium. And what this says is the total pressure is the sum of all of the partial pressures added up. So total pressure, P total, is equal to pressure 1 plus pressure 2 plus pressure 3. We can also talk about percentages. So pressure 1, so the pressure of gas 1 is equal to the percentage of 1 times the total pressure. And we'll talk about how we can apply this equation in a few minutes. But for now, know that Dalton's law only talks about a mixture of gases when we're talking about pressures of multiple gases in the same container. So what this diagram shows is how to find the total pressure of a mixture containing hydrogen and helium. So we know that the pressure of hydrogen is going to be 2.9 atmospheres, and the pressure of helium is going to be 7.2 atmospheres. That means the total pressure is going to be 2.9 plus 7.2, which is going to give us 10.1 atmospheres. So we can see that for each one, when we've got moles of hydrogen, moles of helium, to find the total pressure, we just add up the pressure of helium plus the pressure of hydrogen. Same to find the total number of moles, we add up moles of hydrogen, moles of helium, and get a total of 2.10 moles of gas. So let's look at how we can solve a problem with Dalton's law. Now we know that air contains oxygen, nitrogen, carbon dioxide, trace amounts of hydrogen, some other gases. We want to find out the partial pressure of oxygen if we know the partial pressure of nitrogen, carbon dioxide, and other gases. So we know that our total pressure is going to be 101.3 kilopascals. So this is our total pressure. Pressure 1 is going to be, the pressure of nitrogen is going to be 79.1. The pressure of carbon dioxide is going to be 0.040. And the pressure of all the other gases is going to be 0.94. All of them measured in kilopascals. So we know that pressure total is going to be the pressure of nitrogen plus carbon dioxide plus the other gases plus the pressure of oxygen. So now this is a very simple equation to solve once we plug it in. Pressure total, we know that's 101.3. Plug in all of our other partial pressures. And now all that's left to do is to solve for the pressure of oxygen. We know that 101 is equal to 80.08 plus the pressure of oxygen. So the pressure of oxygen must be 21.22 kilopascals. And here, we want to round it to 3 different figures based on the number of places filled in after the decimal. So here we're just going to round it to 21.2. So that's going to be our final answer. The pressure of oxygen is going to be 21.2 kilopascals. Now in our next sample problem, we want to look at calculating the percentage. So we know that a gas contains nitrogen and oxygen, and it contains 28% oxygen. So if we know the total pressure is 2.0, we want to find the partial pressure of oxygen. How much pressure does oxygen exert by itself? To do this, we're going to use our equation. We know the percentage of oxygen. We know the pressure total. We want to use our equation that the partial pressure is equal to the percentage times the total pressure. So the pressure of oxygen is equal to the percentage. Here we want to convert the percentage to a decimal point. So instead of 28%, we're going to write that as 0.28. Multiply times the total pressure, which is 2.0 atmospheres. And simple multiplication, we know that the pressure of oxygen is going to be 0.56 atmospheres. And those are the two ways we can solve problems using Dalton's laws. Either by looking at the partial pressure, the percentage, and the total pressure, or by adding up all the partial pressures to get the total pressure.